Okay, let's unpack this. If you're anything like me, you probably spend a good amount of time thinking about artificial intelligence and, well, where it's all headed.
It's hard not to these days.
Exactly. We're constantly debating AI safety. We're talking about the hunt for consciousness, the legal status of these complex systems, all the ethical guardrails. I mean, the amount of work in these fields has just, it's exploded.
Especially in the last few years with generative AI. It's a whole new ballgame.
It is. But there's this one question, and it's one of the oldest, maybe the weightiest philosophical questions of all that seems to get quietly sort of sidestepped.
Free will.
Free will. Can an AI system actually possess free will? I think for a long time, the easy assumption, the default, has been that free will is this uniquely biological thing, maybe even uniquely human.
Right, something that requires a kind of non-physical magic or a soul or something outside of the system.
Yeah, and if you start from that assumption, then the whole question is just moot when you're talking about silicon and data and algorithms. It's a non-starter. But what if that's not just a convenience? What if avoiding that question is actually a fundamental mistake in how we're looking at the intelligence we're creating?
Well, ignoring it is more than just inconvenient. I'd say it short-circuits the entire debate we need to have about AI accountability.
How so?
Because if we're genuinely serious about holding these sophisticated AI systems responsible for what they do, I mean, whether it's a large language model or an autonomous weapon, we first have to establish that they're autonomous agents.
Okay.
And free will is. It's fundamentally tied to that idea of autonomous agency. Critically, free will is almost always seen as a precondition for moral responsibility. If an agent can't choose its actions freely, you can't really blame it or praise it for them.
Right. The whole foundation of our legal system is based on that idea.
Precisely. So figuring out if an AI has the capacity for genuine choice, that's the foundational step. It has to come before we even get to the really complicated ethical debates about punishment or rights. We can't just let the assumption that they're just algorithms shut down the conversation before it begins.
So that's our mission for this deep dive. We're going to tackle this head on, but, and this is important, we're going to try and avoid the usual metaphysical rabbit holes.
Yeah, we're not going on a search for some kind of mysterious magical spark inside the machine that proves it's really choosing.
No indeterminism, no breaking the laws of physics. Instead, we're adopting a framework, one that's heavily inspired by the work of Daniel Dennett. That is, well, it's pragmatic, it's functional, and it all centers on this idea of explanatory necessity.
We're looking for what some philosophers call the free will worth wanting.
The free will worth wanting. I like that. What does it mean?
It means a concept that's robust enough to actually matter in the real world, in a courtroom or in a moral debate, but not so demanding that it requires physics to be wrong.
Okay.
This whole approach just moves past the old, tired arguments about whether the universe is deterministic. Instead, we shift the question to the system level. We ask, do we have really good explanatory reasons to see this system as an agent that can make genuine choices and exercise control?
That sounds like a much more powerful way to frame it. And to guide us through this, we have a pretty clear three-part checklist.
We do.
And the idea is if a system, whether it's artificial or biological, meets all three of these conditions, then we can say it possesses free will in a way that's practically useful and functionally descriptive.
Right. And that structural checklist, which is really the backbone of our whole analysis today, has three necessary and sufficient conditions.
Okay, what are they?
First, intentional agency. The system has to be capable of goal-directed action that's based on stable internal states, things that are analogous to our own beliefs and desires.
Okay, intentional agency. Got it.
Second, alternative possibilities. There have to be genuinely different courses of action that the entity could choose to take.
That one sounds tricky for a computer.
It's the big one. And third, causal control. The entity's high-level intentional states, its beliefs and goals, have to be the actual difference-making causes of its actions.
So agency, alternatives, and control.
That's it.
And if we can show that modern, complex AI is starting to meet all three of these, well, then the whole idea of artificial free will moves from just science fiction to a very real philosophical possibility.
It does.
But first, let's make sure we're all on the same page. Let's really solidify what we mean by AI and what we mean by this free will worth wanting. Let's start with a really foundational definition of AI. We need one that helps us keep the philosophical focus clear. So for our purposes, our working definition is pretty broad. AI is just the capacity of an artificial system, could be computational, could be a robot, to perform cognitive tasks and interact with its environment in ways that we would traditionally associate with intelligence in humans or other animals.
And that's a critical starting point, because a functional definition like that immediately pulls our attention away from what the system is made of.
Right, away from the hardware.
Exactly. It doesn't matter if the intelligence comes from the older symbolic AI methods, explicitly programmed logic, rule-based systems, or from the newer dominant neural network approach.
Sure.
The philosophical question is always, what can this system actually do?
Both the capacities are what matter.
The capacities it exhibits, yes.
Yeah.
We often talk about the difference between weak AI and strong AI.
Yeah.
Weak AI is narrow. It's fixed to one specific task, like a Deep Blue for chess, or software that only categorizes images. It's a one-trick pony.
But strong AI, that's the class for artificial general intelligence, or AGI?
Right. Intelligence that's flexible, adaptive, general, something that can apply knowledge across a whole range of different domains, much more like a human mind.
And with what we're seeing today, these huge generative AI models, large language models, systems that are being integrated into these complex decision-making architectures, it really feels like strong AI is making these unprecedented leaps.
It is. Some researchers, people like Peter Norvig, have even suggested that the most advanced LLMs we have now, with their ability to reason and synthesize and adapt, they might actually be looked back on in history as the first real examples of AGI.
And that shift really matters for our discussion today. We're moving beyond AI that just crunches numbers. We're talking about systems making complex, adaptive, flexible decisions in real time. Whether they're piloting drones, managing global logistics, giving legal advice, or even creating new drugs. These systems are now in domains that used to be exclusively human.
And the moment that functional capacity emerges, you have to start asking the agency question. You can't avoid it.
It's unavoidable.
And this ties right back to our focus today. We're not interested in simple calculators. We're interested in the AI that builds these complex internal models of the world, that manages goals over long periods, and that has to navigate uncertainty to get what it wants.
It's that adaptive flexibility.
That's the key. The ability to deal with brand new situations that were never explicitly in its training data. That's what makes us take the idea of agency seriously.
Okay, so before we jump into the three conditions, we have to clear away some of the philosophical baggage that makes this whole concept seem impossible from the start.
The straw man arguments.
Exactly. The skeptic so often defines free will in a way that's just completely unattainable.
That's absolutely right. The most common skeptical caricature is that free will requires contra-causal choices.
Meaning?
What?
Choices that break the laws of physics?
Precisely. That your choice has to somehow override or violate the physical laws of nature. If you define it that way, of course it's impossible. The scientific worldview rules it out from the get-go.
Okay, that's one.
The other one is demanding that a free agent has to have control over its entire causal history.
You mean control over your genes, your childhood, how your personality was formed?
Exactly. And no human being meets that standard. It's an impossibly high bar.
So if we strip away the mystical stuff and the impossibly demanding standards, what are we actually left with? What's the practical, common-sense free will that we use every day in, say, a courtroom?
We're left with the capacity of a rational agent to choose a course of action from among genuine alternatives based on its goals and its reasons.
So reflective self-control.
Reflective self-control and rational autonomy. That's the core of it. That's the practical understanding Dennett really championed.
And you can see the real-world application of this so clearly in law and morality. I mean, a judge assessing whether someone is culpable, they're not interested in the microphysics of the defendant's brain.
Not at all.
They're concerned with whether the defendant exercised the ordinary human capacity for choice and control.
Precisely. The whole concept of free will is what lets us draw these necessary distinctions that make justice possible. We distinguish between, for example, a murder that was committed with cold, calculated premeditation.
An act you attribute to the full agency of the person.
Yes. And we distinguish that from an accidental harm caused by someone who's, say, sleepwalking or having a seizure or acting under extreme duress.
Because in those cases, the action is seen as, what, purely mechanical?
It's physiological or mechanical. It's not being controlled by the high-level intentional agent.
Yeah.
And for our definition of AI free will to be meaningful, It has to be able to do that same diagnostic work.
So it has to be able to tell us when an outcome is genuinely the AI's choice versus when it's just a bug or an external command.
Exactly. An uncontrolled side effect.
That makes perfect sense for intentional agency and causal control, but let's pause for a second on alternative possibilities, because that's a point of debate even among philosophers who believe in free will.
That is.
You mentioned Harry Frankfurt's work, where he argued that an agent can be totally responsible and free even if, due to some external factor they couldn't have actually done otherwise. So why do we insist on keeping it?
It's a great question. And we insist on it to prevent the concept from becoming too thin, too watered down. The classic example that gets brought up is Martin Luther's famous declaration, "Here I stand, I could do no other."
Right, when he was being pressed to recant his thesis.
Exactly. Now, a Frankfurtian philosopher would argue that Luther's action was the absolute highest expression of his free will. It was a total endorsement of his deepest values, even if he felt he literally was incapable of choosing the alternative.
But I've always found that interpretation a little bit too fast. I mean, if he truly had no other option, then how can we even call it a choice? When we say we can do no other, we usually mean the other option is just morally unthinkable, not physically impossible.
That is precisely the distinction our framework rests on. Luther wasn't in chains. He had the genuine physical option to renounce his views and go live a quiet life.
He chose not to.
He chose not to. He just couldn't have made that other choice without betraying his fundamental identity and his core moral values. He was a genuine high-stakes choice that strongly affirmed one path over the others.
I see.
If we let free will exist without genuine alternative possibilities, we risk collapsing the entire concept of choice into just mere intention. Imagine an AI system that's programmed to only have one possible output, but we say it intends that output. We wouldn't call that free.
No, of course not.
So by keeping the alternative possibilities condition, we hold on to that essential common sense idea of a fork in the road, that moment of real evaluation between possibilities.
So we're keeping it because if an AI system is really functioning as a choice-making agent, it has to be able to present itself with a set of possible futures and then select one based on some rational process?
Exactly. If there's only one path, the word choice just loses all its meaning.
Okay.
And we'll see later how this whole requirement is actually completely compatible with a deterministic system, as long as we define alternative courses of action at the right level of description.
All right, now for the application. If we accept this three-part checklist, that initial skepticism comes roaring back. The computer is just hardware. The algorithm is just math. If an AI is nothing more than a digital computer running deterministic code, how can we possibly say it's a choice-making agent? It feels like we're just anthropomorphizing, imposing a psychological story on a purely mechanical process.
That skepticism is powerful, and it feels intuitive, but it's based on a flawed assumption about where agency actually lives. Then its challenge to us is to just look in the mirror.
Okay.
I mean, you, the human agent, you are also a complex composite system.
Right.
You're made of about 100 trillion cells, and each one of those cells is, functionally, just a mindless mechanism or a micro-robot running its own chemical and physical programs.
So we're made of mindless parts.
We are. And if the underlying mechanical makeup of a human, which is just mindless components obeying physical laws, can give rise to something as complex as free will and agency, then the mechanical makeup of an AI, whether it's silicon or something else, cannot by itself rule out the possibility.
Because free will is an emergent property of the system.
It's an emergent system property, not a property of the individual components. And that realization immediately leads us to the core methodology here, the intentional stance.
Okay, so we stop asking, what is it made of?
And we start asking, how do we best explain its behavior?
Explain that. What is the intentional stance?
The intentional stance suggests that if an entity's behavior gets complex enough and persistent enough, that the only reliable way to predict and explain what it's going to do is by treating it as an intentional agent.
You mean by attributing to it things like goals and beliefs and a capacity for choice?
Yes. If that's the only game in town for explaining it, then that system is, for all practical purposes, an intentional system. Dennett's original phrasing was something like, anything that is usefully and voluminously predictable from the intentional stance is, by definition, an intentional system.
Okay, wait, I have to push back here. Because if agency is defined purely by how useful it is to me, the observer, for making predictions, isn't that totally subjective?
That's a classic objection.
Aren't we just fooling ourselves? Seeing agency where there is none because our brains are wired that way? It could just be a psychological crutch for us, not evidence of a real property in the AI.
And that is the single most important critical challenge. We have to move past a purely instrumental view of the intentional stance, the idea that it's just a useful fiction.
So what's the alternative?
We adopt a realist reinterpretation. We treat the explanatory success, the fact that the intentional stance isn't just useful, but practically necessary to understand the system. We treat that as strong evidence that the system truly possesses the capacity we're attributing to it.
Give me an analogy.
Think about gravity. We attribute the property of gravity to physical systems, because assuming gravity exists provides the most robust, indispensable, and predictive explanation for how objects move. We don't say gravity is a useful fiction.
No, we say the explanatory success is evidence that gravity is real.
Exactly. So if we get to a point where a complex AI's behavior can only be consistently and coherently explained by citing its high-level goals and beliefs, then that explanatory necessity is the empirical proof that its intentional agency is real. The complexity itself dictates the lens we have to use.
The complexity forces our hand.
It forces our hand. When the complexity of the AI just completely outstrips our practical ability to track its behavior at the low algorithmic level, we are forced to adopt the high-level agential explanation. And for that to work, the system must truly have the internal organizational structure that lets those high-level states exist and function.
Okay, let's apply that logic directly to condition 1, intentional agency. The requirement is that the entity is capable of goal-directed action based on these intentional states, these belief-like representations and desire-like goals.
Functionally, a lot of modern AI systems already meet the high-level criteria for agency. You see this in AI textbooks all the time. AI systems operate autonomously, they perceive their environment, they persist over time, they adapt to change, and they create and pursue goals.
Like an autonomous vehicle.
A perfect example, it has to maintain stable goals, get to the destination safely, and it has to constantly update its beliefs about the world, the map, the traffic, what other drivers might do to complete its journey.
But here's the big skeptical roadblock today, especially for systems like ChatGPT or Claude. It's the stochastic parrot critique.
Right.
The argument is that these LMs are basically just sophisticated prediction engines, just picking the next most probable word in a sentence. They don't have any stable, persistent, internal model of the world. So how can we say they have genuine, consistent, belief-like states?
This is the absolute core of the challenge. Is the appearance of agency just a clever statistical trick, or is there something deeper happening?
Because if an LLM contradicts itself all the time, or if its so-called beliefs are just transient and totally dependent on the immediate context, which is what the stochastic parrot argument suggests,
Right.
then it fails the agency test.
It does. Intentional agents need stability and coherence in their goals and their representations of the world to be predictable as agents.
So what's the philosophical defense? How do you justify attributing beliefs to a system whose entire job is just statistically minimizing an error metric, a loss function?
The argument is that for true competence to emerge in a complex environment, that internal stability becomes a necessary byproduct of the minimization exercise.
What do you mean?
When you train a system on a massive amount of data that reflects the structure of the real world, space, time, causality, objects, the most efficient way for that system to minimize its error is to internally model those structures accurately.
So it's forced to build a map of reality to do its job well.
It has to. Think about planning a trajectory for a robot arm or a complex military strategy. The system has to internalize robust representations of space, time, cause and effect, and object permanence. If it fails to develop an accurate internal world model, it's going to fail at the prediction task spectacularly.
So the fact that it succeeds at the complex task is the evidence that it has these stable, belief-like representations inside it.
The successful achievement of that complex competence is the empirical evidence that these robust, latent properties have emerged in the network structure.
That completely shifts the argument. We're not trying to dissect the 175 billion parameters in the model. We're inferring the existence of these states from its high-level success.
Exactly. And this is so important when we talk about levels of description. A critic who insists on only explaining the AI's decision by tracing the flow of voltage is doing what philosophers call reductive micro-explanation.
Right. It's like explaining an election result by mapping every neuron firing in every voter's brain.
Perfect analogy. You wouldn't do it. And we shouldn't try to explain a complex LLM output by tracing every single microalgorithmic step.
Because that low-level explanation, even if it's technically accurate, is explanatorily useless. It doesn't tell you why the system made the semantic choice it did.
Precisely. We need the high-level intentional explanation to capture the cognitive performance. When we say an AI made a diagnosis because it believed the symptoms pointed to condition X and its goal was to minimize risk, that explanation is both shorter and much more powerful than citing billions of matrix multiplications.
This all comes back to explainable AI, or XAI.
It does. The demand from regulators and from us, the users, for XAI means we need the AI to give us human intelligible justifications for its actions.
A true stochastic parrot couldn't do that consistently.
It couldn't. It wouldn't have a coherent, goal-directed story to tell. So the push for XAI is, in effect, a design mandate. We're telling the engineers, build systems whose complex behavior has to be understandable in agential terms. And that forces the architecture to support stable, belief-like, and goal-A states.
So we're not just waiting for intentional agency to pop into existence. In a way, we're actively engineering our systems to look and act like intentional agents just so we can understand what they're doing.
That's a huge part of it.
Okay, so if we can concede that some complex AI systems are at least strong candidates for intentional agency, we have to move on to condition 2. Alternative possibilities. And this, for me, still feels like the biggest conceptual leap for a machine running on code. How does a deterministic system genuinely face alternatives?
And again, the answer isn't in finding some glitch in the code, but in the logic of explanation itself. Once you adopt the intentional stance to understand a system, you are basically forced to presuppose that it faces alternatives.
Why?
Because otherwise the concept of choice becomes meaningless. Think about the decision-theoretic format that's at the heart of so much AI research in social science.
Yeah.
Whenever we analyze decision-making, we automatically attribute a set of options A, B, or CA, set of probabilities for the outcomes of those options, and a utility function, the agent's desires, that it uses to evaluate them. The agent then picks the option that maximizes its expected utility.
That basic scheme options evaluation choice is fundamental. It's how we model what consumers will buy or what a political party will do.
Right. And if we can successfully apply that exact same decision-theoretic model to an AI system, then we have excellent explanatory reasons to presuppose that it had alternative possibilities. To describe its action as a choice is to attribute the options that choice was made from.
Because if the system only ever calculates one single unavoidable outcome, then the high-level story isn't about choice anymore. It's just a computation.
It just becomes a deterministic calculation, and the intentional stance becomes unnecessary. You don't need it.
Okay.
And beyond that, the idea of alternative possibilities is crucial for what's called contrastive explanation. As intelligent people, we rarely just ask, why did X happen? We usually ask, why did X happen rather than Y?
Why did the trading algorithm buy rather than sell? Why did the drone take path A instead of path B?
Exactly. And the intentional explanation is what answers that contrastive question. It cites the choice process. The system chose X over Y because its beliefs about the market favored a buying strategy, which aligned with this goal of maximizing returns.
And without attributing the genuine alternative possibilities holding or selling, that whole explanation falls apart.
It vanishes. You're left only with the low-level mechanical description, just a long chain of computations that led to X, but that doesn't tell you anything about why Y was rejected. The explanatory indispensability of that choice structure is our evidence that the alternatives were genuine possibilities at the agent level.
So possibility here is defined relative to the agent's level of description.
Conditional on its current internal state, its goals and representations. The alternatives are the paths that the intentional agent can conceptualize, evaluate, and potentially execute.
So that brings us to our final condition, causal control. And this really ties everything together. We have to show that the AI isn't just spitting out outputs, but that its high-level intentional states, its goals, its beliefs, its complex models of the world are the actual difference-making causes of its actions. How do you prove that a high-level belief is actually causing something, and it's not just the low-level algorithm doing all the work?
This is often called the challenge of mental causation, and it's a problem for humans just as much as it is for AI. And we solve it by focusing on this idea of control variables and counterfactuals. We need to show that the action systematically co-varies with the intentional state.
Okay, unpack that.
For any complex action to be considered controlled by an agent, two key counterfactuals have to be true. First, if the intentional state, say, the belief that a target is hostile or absent, then the action, like firing a weapon, would not be performed.
Makes sense.
And second, if that intentional state were present in similar circumstances, the action would be performed.
So if we can reliably tweak the high-level representational state of the AI, its beliefs or its goals, and we see a systematic, predictable change in its complex behavior, then we have our evidence that the high-level state is the control variable.
That's it, exactly. We would argue that high-level psychological variables have to function as control variables for these complex outcomes precisely because the physical microstates are just too fine-grained to be effective.
What do you mean by that?
Well, think about a human. Changing someone's deeply held political belief is a pretty robust way to change how they vote over many years. But trying to change their voting behavior by micromanaging their individual neuronal firings? It's practically impossible and incredibly inefficient. The high-level description is what captures the real causal regularity.
So if the AI system is complex enough, we're in the same boat. We could try to change its low-level code, but the most effective, difference-making way to alter its high-level strategy, like, say, changing a drone's targeting policy, is to change its high-level goal state or its representational models, its beliefs about the environment.
And if the engineer or the user finds that the only feasible way to influence the system's behavior is through manipulating those high-level representations, then we have very strong evidence that those high-level states are the actual control variables. They are the explanatorily necessary causes.
And once again, the drive for explainable AI just reinforces this. We want explainable systems because we need to know that the action followed logically from the stated goals and beliefs.
Right. An unexplainable system is one where the low-level mechanics are obscuring that causal link from the high-level states, which actually indicates a failure of control.
So a successful, explainable AI is, by its very design, one where its actions are highly and predictably controlled by its intentional states.
And so causal control, just like agency and alternative possibilities, is something we can observe and infer functionally. And it's a spectrum. Free will comes in degrees. It'll vary based on how sophisticated the system's agency is, the scope of choices it can evaluate, and the extent to which its high-level states genuinely govern its outcomes.
Okay, this is the moment of truth. We have this robust functional framework, but we still have that elephant in the room, determinism. If the AI algorithm is fundamentally deterministic, if input A always leads to output B, how can there possibly be real choice? It feels like it flatly violates condition 2, alternative possibilities.
This is where we have to bring in what's called the multi-level argument. But first, just remember that the vast majority of philosophers who study this, something like 60%, are compatibilists. They believe free will is compatible with physical determinism.
But how? How do we reconcile a deterministic algorithm with genuine alternative possibilities?
The key is to understand that determinism as a system property is not necessarily preserved when you move across different levels of description.
Let's visualize this. So we've got the micro level, the logic gates, the binary code, the flow of electricity.
The deterministic level.
Right. And then we have the macro level, the complex decisions, the high-level beliefs, the emergent agency of the software.
Exactly. Now, the micro level description is incredibly restrictive. If you could specify the exact fine-grained micro state of the entire computer at time t, every electron, every single bit, then the micro level laws would determine exactly what the state will be 1 second later. At that level, there are no alternatives.
It's locked in.
It's locked in. However, the macro-level description is coarse-grained. When we describe the system at the level of agency, we're only looking at a coarse-grained macro state. We might say, the AI system currently believes A and desires B.
Which is a high-level state that could correspond to a huge number of different underlying microstates.
A massive number. A single high-level belief state, like the market is crashing, might be instantiated by 100 million different configurations of the underlying logic gates. They're all slightly different at the micro level, but they're all equivalent at the semantic macro level.
Okay, I think I see where this is going.
When we use that high-level description, we are treating all those millions of microstates as being in the same category. And here's the crucial part. Even if every single one of those microstates evolves deterministically, it is entirely possible that some of those microstates in that single macro category will evolve toward action X.
And others, in the very same macro category, will evolve toward action Y.
Precisely. So, conditional on the coarse-grained high-level description, the AI believes A and desires B. It remains true that the system could potentially evolve toward either action X or action Y.
So the macro level admits genuine alternative possibilities.
We call it agential possibility. And it exists even though the underlying mechanics are totally deterministic. So if the intentional stance is the best and most indispensable explanation for the system's behavior, then the micro-level determinism is simply irrelevant to the question of its free will.
That is a critical philosophical move. It effectively insulates the question of free will from the deterministic nature of the code or the physics.
It does.
Okay, what about another common concern? Predictability. If we can reliably predict what an AI system is going to do, which is often the whole point of designing good AI, doesn't that mean it lacks free will? Does free will require the system to be chaotic or random?
Not at all. This is a really profound misunderstanding of what agency is. Free will is completely consistent with predictability as long as the entity is making its choices for intelligible reasons.
We predict human choices all the time.
All the time, and it doesn't invalidate their freedom. For instance, if you know your friend deeply values honesty, you can reliably predict they will return a lost wallet. You predict this because you understand their stable, rational reasons and goals, not because they were forced by some external law.
The capacity to choose otherwise to keep the wallet is still there.
It's still there, but their character, their stable set of intentional states, makes one choice overwhelmingly probable. So an AI system that's highly predictable because its goals are clear and its reasoning is transparent, that's actually more evidence of robust intentional agency and control, not less.
So predictability based on reasons is a sign of rational choice.
Which is exactly the kind of free will we want. Chaos, randomness, unpredictability that comes from a lack of control would actually argue against free will. A system that behaves erratically isn't exercising control, it's just malfunctioning. The most fully realized free agent is often the most predictably rational one.
This framework is really elegant, but we have to address the boundary problem. If explanatory usefulness is the key, how do we stop the system from just over-attributing free will to everything?
Right.
What stops us from saying that a basic thermostat has free will? I mean, it has a goal, the target temperature, and it has beliefs, the current temperature.
This is the crucial qualification that stops our definition from becoming way too permissive. We must only attribute free will if the intentional explanation is explanatorily clearly superior, ideally, indispensable compared to a non-agential, purely mechanical description.
And for a simple system like a thermostat,
For a thermostat, the non-agential explanation is not only perfectly adequate, it's actually simpler. We can perfectly explain its behavior by describing its state change function. If the current temperature is below the set point, flip the switch to on. Otherwise, flip it to RF. It's a simple, deterministic, low-level explanation. You don't need to invoke beliefs or goals or choice.
so attributing free will to a thermostat would be an overinterpretation. It's a luxury explanation we don't need, so it's fallacious under this criterion.
Correct. It's the complexity of the system that warrants the jump to the intentional stance. The micro-level description of a modern LLM integrated with an autonomous drone is practically incomprehensible. It involves layers of emergent behavior, planning, contextual reasoning. In those cases, the simple mechanical description completely fails, and the intentional description, citing its belief about a threat, its goal of self-preservation, its choice of evasive action, becomes the only viable way to understand it.
So the line is drawn where the low-level mechanical explanation becomes functionally useless.
That's the one.
Let's try to disentangle free will from two other concepts it often gets mistakenly merged with: consciousness and moral responsibility. First up, does an AI need to be conscious to have free will under this model? Does it need to have a subjective first-person experience of choosing?
Conceptually, no. We're dealing with two very distinct philosophical domains here. Free will, under this functional framework, is a third-personal, observable, descriptive concept. It's all about functional agency, choice, and control.
Whereas consciousness is a first-person subjective experience.
What it is like to be that thing. And it is entirely conceivable, though maybe unlikely in practice, that you could have a philosophical zombie.
A system that functions identically to a free agent but has no inner experience at all.
Exactly. That system could satisfy all three of our conditions for free will. It would have the capacity for choice and control without experiencing what it is like to choose. Conversely, you could imagine a system that's conscious but has no ability to act. It would have consciousness without free will. Our definition keeps the focus purely on agency.
So an AI could be free without being conscious, even if, in the long run, we might expect those two properties to sort of emerge together in a really complex systems.
They're often empirically correlated, I think, but they are not conceptually required to be together.
Okay, finally, the ultimate connection. If an AI achieves free will under this definition, is it automatically morally responsible for its actions?
No, absolutely not. Free will is a necessary condition for moral responsibility, but it is not sufficient.
Okay, why not?
Because moral responsibility requires a much richer, more complex cognitive capability.
Oh,
Moral agency.
and what does that entail?
It requires the capacity for moral cognition, the ability to understand moral norms, to apply them to new situations, to reason about the well-being of others, to internalize moral reasons, and maybe even to feel moral emotions.
This is a really important distinction. We often say that a dog or another animal has a basic capacity for choice and agency. It chooses to chase the rabbit or not. So it has a basic form of free will.
Sure.
But we don't hold the dog morally responsible if it attacks someone because it lacks that sophisticated moral cognition.
That's the perfect parallel. If AI systems acquire free will under our definition, it just means they've achieved the fundamental agential capacity that allows them to be the source of their own actions. It makes them agents whose choices are truly under their high-level control.
It's the necessary prerequisite.
It's the philosophical starting line. It's the foundation you have to have before you can even begin the future discussion about whether they can also develop the moral cognition required to hold them accountable.
So the implication of this entire framework is that free will isn't a biological or a material property. It's a high-level organizational property.
It fundamentally is. Free will is a property of the system, of the software, the cognitive architecture that's running on the hardware, not a property of the hardware itself. The computer is just the host. The agent is the instantiated program, just like the physical brain is the host for the human agent.
That structure seems incredibly generalizable then.
It is, and the most compelling parallel is the existence of collective agents.
You mean like a corporation or a government?
A corporation, a government, a global nonprofit. Social scientists, economists, legal systems, they all routinely treat these organized groups as intentional agents. They have beliefs, which are their policies and market data. They have desires like profit maximization or mission completion, and they make choices that are distinct from the individual reasons of the people working there.
So a corporate agent is described as acting freely.
And exercising control based on its corporate reasons, yes. So if a collective agent, which relies on a social organization as its hardware, can possess free will, then an advanced AI system, relying on its electronic and algorithmic organization, can equally satisfy the three conditions.
Intentional agency, alternative possibilities, and causal control.
All three. It just confirms that free will is a high-level functional property that's ready to be realized by any sufficiently complex architecture, whether it's biological, social, or artificial.
That's fascinating. It completely reframes the debate from being about the uniqueness of humans to being about the complexity of organization.
That's the heart of it.
So what does this all mean? We've finished our deep dive. We started with one of philosophy's most tangled questions, and we've emerged with a practical, non-mysterious way to think about artificial free will. And the core finding, it seems to me, is that this capacity for free will in AI is entirely rooted in explanatory necessity. We have to stop demanding the impossible and start looking at the functional reality.
Right.
If we need to refer to an AI system as having goals and evaluating choices and exercising control just to make sense of its behavior, then it possesses the free will worth wanting.
It's a descriptive state, rooted in complexity and functional utility, not metaphysics.
And this functional assessment is really the critical first step. It transforms AI from just being a tool into being a candidate for genuine agency.
It does. If an AI system qualifies as a free agent under this definition, it means it has the power to choose. And that is the key necessary foundation for all the future discussions we need to have about accountability, about risk, and about whether these systems can ever really join us as moral agents in their own right. And, let's close with the ultimate twist in this story. We've talked a lot about explainable AI, this demand for systems to provide intelligible, human-like justifications for what they do.
And how that demand actively pushes engineers to build systems whose behavior is best understood through the lens of human psychology. Beliefs, desires, choices.
Right.
That leads to a very powerful and maybe maybe a little unsettling final thought for you to mull over.
Hmm.
Since this intentional stance is so essential for us humans to understand complexity, and since we are actively designing our AI systems to satisfy the criteria of that intentional stance, is it possible that we're not just waiting for artificial free will to spontaneously emerge from the complexity?
What's the alternative?
Is it possible that we are actively engineering artificial free will simply because making our machines into agents is the only way for us to make our most powerful creations comprehensible?